Hello my dear student. So in this video we will learn testing of hypothesis based of mean population based on population mean. Now I am going to discuss this question. Listen carefully. Now, so here the question is a sample a sample of size 200 is drawn with mean 171.38. Can it be regarded as a sample is drawn from the population with mean 171.17 and standard deviation 3.3? Test at 5% level of significance, and the given value is z suffix 0.05 is equals to 1.96. Now first I try to understand. So here one sample information is given compared to the population. Okay, so single mean. So now first you try to understand how to start the calculation. It's very easy. First you have to write down the given information. So first you write down the given information. So first one is for sample and second one is for population. Okay, second one is population. So already you know, in case of sample the mean is x bar. What is the mean is given? Mean is equals to, for sample size of is 171.38. What about the sample size, that is called n? Sample size is equals to 400. Clear? Is there any other information about the sample? No. Now come to the population. What about the population information is given? So here mean. So population means is described by mu. What about that? 171.17. Okay. Any other information? Yes, standard deviation is also given. That is your sigma. Sigma is equals to how much? 3.3. Is it clear? So this is the basic information. So this one is for sample wise, this one is a population wise. So first, this is the first step. First step is all about the information. Whatever the information are given, you need to write. Now come to the second step. What about the second step? So please write down null's hypothesis. Let null hypo. Okay, what is null hypothesis? What about the population? Basically, hypothesis is connected with the population wise, correct? So here you may write null hypothesis means which one is given in population. So here mu is equals to 171.17. Clear? So what about the alternative hypothesis? What about the alternative hypothesis? It is denoted by H1. Now the question is, question is, can it be regarded as a sample is drawn from population? The question is yes or no. If this type of answer is coming, so you can write down the alternative hypothesis will be mu not equals to 1.7117. Is it clear? Here question is whether this sample is coming from this population, yes or no. Okay, so in that situation you should write not equals to. Is it clear? I repeat once again. First step is all about the information based, sample wise and population wise. Okay, after that you need to write null hypothesis and alternative hypothesis. Already I have mentioned that null hypothesis or alternative hypothesis totally based on population wise. Null hypothesis, which one is given? So here population mean is given this. The alternative hypothesis is reverse of that. Reverse of that. Reverse means maybe greater than, maybe less than, maybe not equals to. But in this question, you want to check whether this sample is coming from this population. Your answer will be yes or no. So in that situation, you need to write not equals to. I think it is clear. Is it clear? Okay. So first step information, second step hypothesis wise null as well as alternative. Null hypothesis always equal to sign, alternative hypothesis based on the situation greater equals to, less than equals to, or not equals to. So already you know, if I have not equals to, so here you should mention this is two tail test. Okay, so that means you need to consider both left hand side and right hand side, plus minus both. Okay, our second step is over. Now come to the third step. What about the third step? Please write down test the test statistic. The test statistic is, so here z is equals to x bar minus mu by sigma by root n. Clear? So this is the formula. But here you can see, here you have considered not equals to. So in that situation you need to calculate mod. Is it clear to all of you why I am taking mod? Because not equals to you have in alternative hypothesis, not equals to you have, that's why you should consider both. Okay, now you know what is the value of x bar. What about the x bar from the previous? What about the x bar mu? All you know. So here you write down once again, x bar is equals to 17.138. What is sigma? Sigma is equals to 3.3. What is n? N is equals to 400. What is mu? Mu is equals to 171.17. I think it is clear to everyone. So these are all coming from the previous slide. Now we substitute one by one. 171.17 minus 171 from 38 minus 171 from 17 divided by sigma, that is your 3.3 whole divided by root under 400. Is it clear? If I simplify, how much is coming? So it is coming 0.21, and here it is coming 3.3 by 20. Please check carefully. So ultimately it is coming 4.2 by 3.3. So your result is coming mod value 1.27. Okay, is equals to 1.27. Okay, so whatever the result is coming from the test statistic, this is called Z-cal. So this is very important information. Z-cal. Okay, Z-cal means CAL stands for calculated value of Z. Okay, is it clear? So this is about the third step. The using state statistics, you find the value of Z-cal. Is it clear? Okay. Next step is write down the level of significance. So write down the level of significance. The level of significance is at 5%. Okay, so here Z 0.05 is given. 0.05 is given, that is your 1.96. Okay, so this is your Z tab. That means this one is value is coming from table. Okay, standard normal table. This value is coming from standard normal table. Clear? Okay, you may consider mod also, there is no issue. Now you need to write this line. So this step is fourth step. So this information is coming from at what level of significance you want to calculate. Okay, next you write down now. Now zcal, and you write down z tab. What about the zcal? What about the zcal? If I go back, zcal is equals to 1.27. What about the z tab? 1.96. Which one is big? Which one is big? This one is big. So you write this. Is it clear how to decide this? Less than sign. Is it clear? Because from here it is clear that z tab is equals to 1.96. What about the zcal? Zcal is 1.27. Zcal is 1.27. Clear? So you write down this one. Now you draw the curve. Now you draw the curve. Okay. Now from here it is clear. So this is your rejected region. Now from here it is clear. So your zcal is lies here. Your zcal is lies here. Is it clear? Because what is your zcal value? Your zcal value, zcal is 1.27, which is less than compared to this should be here. Okay, now what about the position? This one, this headed region is called rejected region, and these two are called accepted region. Okay, clear? So please write down, please write down here. Here zcal is equals to how much? You have 1.27. 1.27 lies in the accepted region. Accepted region. So null hypothesis is accepted. Okay, so that means in null hypothesis you have considered sample is coming from population, same population, and alternative is sample is not coming from the same population. So here null hypothesis is accepted. It means what? Write down the conclusion. The sample is from given population. Is it clear? Is it clear? Sample is coming from given population. So this is the answer. Okay. So if I can recapitulate, so there are total five steps you have. Okay, total five steps. Now here we have considered two-tail test. Why it is called two-tail test? That means you should consider in both ending position. These two are called left tail and this one is called right tail. Okay, so if I can go back to the first slide. So this one, this given information, okay, this information is all about the step one. Is it clear? Step 1. What about the information you have? That is called step 1. The second step, That is your hypothetical part, hypothesis part. This is your step 2. Is it clear? This is your step 2. Clear? I think it is clear. Third one, the test statistic. This one is your step 3. Okay. So first step information, second step hypothetical area, null hypothesis, already hypothesis. Third step is all about the state statistic. Okay. Now fourth step is all about the given information, that at which level, at what level you want to test it. So here the level of significance is at 5%. Okay. And last step is conclusion, comparison, and then this one, that is a total, this up to this step 5. So where you need to compare ZCal and ZTAF, and you draw the curve, and you have to identify whether your ZCal value lies in the critical region or in the accepted region. If your ZCal value lies in the accepted region, these two are called accepted region. These two are called accepted region. Okay. And this one is called rejected region. Rejected region. So here this value lies in the accepted region. So null hypothesis is accepted. That means what? You have considered in null hypothesis that the given sample is from given population. So which one already have mentioned as a conclusion. Okay. So this is all about the solution process.